question 7. So, have a good close look at the diagram, that's important. Remember, the friction is mu times r, where r is the force upwards here. Now, the other thing to bear in mind is we're told that tan alpha equals 3/4. That allows us to work out what sin alpha and cos alpha are, just from a right-angled triangle. Now, for part A, the answer is just that it's an inextensible string. For part B, we resolve up and down to get an equation with regard to B, and we resolve up the slope for A, giving us these two formulae here. Now, in order to work out the acceleration from these, we need to do one final elimination. We need to be able to eliminate F. So we know F is 1/4 of r, so we need, because F is mu r, so we need to find out what r is, and in order to do that we resolve in this direction, which I've done here. So we work out that r equals 2mg cos alpha. So we now know that F, which is 1/4 of this, so basically we're now left with just the one unknown, because the m's cancel, g is obviously 9.8, so that allows us to work out that A is 0.4g or 3.92. Now for part D, really we're going to end up, we've got to work out what the distance xy, so we're going to end up using v squared equals u squared plus 2as. So we need to do two preliminary calculations. We need to work out what the initial speed is, and we need to work out the acceleration. Now the initial speed of A is going to be the final speed of B. When I say the initial speed, I mean the initial speed for the second part of the journey. So once it's on its own, once B has hit the floor, what is that initial speed as A as it carries on going up the slope once B has hit the floor. So the initial speed of A for the second part of the journey is going to be the final speed of B. So we work out the final speed of B using CVAT, and we get v squared equals 0.8 gh. So this is going to be the initial speed for A. U squared is 0.8 gh. So that's the first thing. Secondly, we need to know the acceleration of A. So to do that, we resolve up the slope. F equals ma, so we just substitute in, and we get A being minus 0.8 g. So substituting in, this gives us that our distance is 0.5 h. So that's the second distance. That's the distance that A goes after B has finished its journey. So we need to add on that initial h, because as B goes down h, A goes up h. So A's first part of the journey is h, and then its second bit, once it's on its own, is 0.5 h. One bit I forgot to emphasize, obviously once B has hit the ground, there is no longer any tension in the string. So that's why we had to rework this here. We now no longer have tension in the string. So that hence the need to rework this here.